Hey Ariana, it's Mrs. Burris. I wanted to go through and go over the exponent practice problems that you completed a couple of weeks ago. Hopefully you're okay. I thought we had a Zoom meeting scheduled today at 12:30. So like I said, I hope you're okay. So this won't take too long, but what I wanted to do was go through these problems, and then next week I would like to meet with you Monday or Tuesday, since Thanksgiving starts on Wednesday. Thanksgiving break starts on Wednesday. I figured if we meet Monday, Tuesday, that will be our weekly meeting. Okay, so let's take a look at the first one. I'm going to be flipping back and forth here through exponent rule notes that I shared with you. So the first thing I wanted to go over with you is just the definition of an exponent. So we know that an exponent is a number that says how many times to use that number in multiplication. So we have 5 to the third power here. Our base is 5. That exponent of 3 tells us that we are multiplying 5 3 times. Same thing with 3 to the second, we're multiplying 3 2 times. Same thing here with 4 to the fifth, we're multiplying 4 5 times. And then the next part of your notes should have been the rules. So the first one here is the product rule. So we have x to the n power times x to the n power, and whenever you're multiplying exponents, you have to add the exponents, even if it is a number. So let's say that we ended up with 4 to the third times 4 to the second. When we simplify that, it would say 4 to the fifth. So you don't have to multiply 4 times 4 times 4 and 4 times 2 to get an actual answer. So like 4 times 4 is 16. 16 times 4, oh gosh, I gotta do that one off the top of my head. 16 times 4 is 64. So you wouldn't go 64 times 16 to solve your answer. So let's look back at question number 1 here. It looks like that is what you did on number 1, is that you actually did 6 times 6 times 6 times 6 5 times, then 6 times 3, 6 times 6 times 6 3 times. But really, all we want you to do on this one is to add the exponent. So it was xn times x to the n means xn plus n. So your answer for this one should have been 6 to the 8th power. We're just looking for you to simplify. Question 2 is correct. It is x to the 11th. I want to draw your attention here, though, to n to the 0 power. This is going to be interesting in algebra because whenever you get n to the 0, it always means 1. So just that'll be something that you'll learn next semester, hopefully in your Apex class. But n to the 0, anything to the 0 power always equals 1. So if it was 4 to the 0, that would equal 1. And I don't know the fancy math explanation of why that is, but I just know that anything raised to the 0 is 1. So even if this was, let's say, so we know that this is 1, it's still, your answer would be, you have x here, your answer would still be n to the 11th. So you got that one correct. Good job. For question 3, you did the right thing where you multiplied your coefficients and got 8, and then you added your exponents, which gave you 10. So your answer is 8k to the 10th. That is correct. Woohoo! Moving on to the next rule is the quotient rule. This is where we have our division, our fraction looking like things. For this one, you're going to make sure that you subtract the exponents. I also like to draw out the problem, and this is called expanded form. I think expanded form is helpful because you can visually see what's happening in the problem. So if we go back to your problem, which is 8 to the 6th over 8 to the 5th, your answer is absolutely correct. But if I wanted to expand that, I would write 6 eighths on top and 5 eighths on the bottom, and then I would cross out them, and whatever was left, that is our answer, which is 8 to the 1 power. So this next problem is a little different because you ended up with a negative answer, which is what you would get. I just have to show you how do you write that as an answer. So I'm going to write it out in expanded form. So there's my 6 p's on tap. Here's my 7 p's on the bottom, so I'm going to eliminate the 6 of them. And you're right, we're left with p to the negative 1 because it's in the bottom. We can't have negative exponents though. So what we have to do is write the reciprocal. The reciprocal is a fancy word for we just flip, we flip the fraction. Well, wait, no, we're not using the reciprocal on this one, I'm sorry. Disregard that. We're actually going to end up writing our fraction with a 1 over p1 because we don't want a negative exponent. We want to keep it positive, so we write it in a fraction as 1 over p over 1. Looking at number 6, it's 49n to the third. I'm going to write this one out in expanded form, so we have 3n's over 7n. So for this one, we actually are going to look at our fraction, our 49/7, and we're going to reduce that. So if we divide 49 divided by 7, we get 7. And then if we do the exponent rule for division, we eliminate, we subtract. 3 minus 1 is 2. So your answer for this one would have been 7n squared. For question 7, we need to look back at the exponent rule. The exponent rule called the power rule. So when we have the power rule, we're multiplying the exponents. So we have x here, m raised to the nth power. So we end up multiplying these two numbers together. Another way is to say this is that if we look at x squared raised to the 6th power, this is telling us we have 6 sets of x squared. So that's why I have x times x 6 times. So let's look back at your problem here. We have 3/8 to the 8th power. 3/8 to the 8th power. So you did the exact right thing. You multiplied your exponents and got 3 to the 64th power, which is correct. For number 8, n to the 5th to the 8th power is absolutely correct. And I'm not going to write this one out, but like you totally could. 1, 2, 3, 4, 5. So there's your first set. There's your second set. There's your third. Fourth. I guess I'll just go ahead and write it all out. So you can see like visually 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So you can see here I have my n to the 5th power 8 times. So if I were to add all those up, they would definitely equal 40, which you got the correct answer because you multiplied 8 times 5. Great job. All right, moving on to number 9. Number 9 has 4n to the 3rd 2 times. So you got this part correct. Your exponent is correct. The part that's missing is the coefficient. So if I write this out, 4n to the 3rd 2 times, we still have these two numbers right here that we have to multiply. So 4 times 4 is 16. So you would have 6n to the 6th power. 16n to the 6th power, excuse me. All right, if we look at 10 we have to simplify. So we have 2x to the 5th times x divided by x. So there's two exponent rules we have to use. For the numerator, for this one, we have to use, go back to the notes, we have to use the product rule first and add our exponents. So if I go back here, you know, this just has like a 1 on it because there's just 1. So we multiply 2 times 1, that gives us 2. And then when we add our exponents, 5 plus 1 is 6 over 6. And now we're back to the quotient rule. So 2, 1, 2, 3, 4, 5, 6, divided by x. We cross out, we subtract 6 minus 1, and we're left with 2x to the 5th power as our answer. Moving on to 2x to the 7th power. 2x to the 7th raised to the 4th power. So this is telling us we have 4 sets of 2x to the 7th. So if I write that out, that looks like this. There's our 2, and we have 7 x's. There's our first set. There's our second set. There's our third set. And there's our fourth set. So again, we have to take our coefficients and multiply them. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So we get 16x. And I like that you have 28 here. That's correct. To the 28th power all over x. So if I were to write all of that out, I'm not going to write 28 x's out, but now we're set up for the quotient rule where we just subtract our numerator and denominator exponent, and we get 16x to the 27th power is your answer. Lots of steps on these ones. And then last but not least, we have our 2n to the 8th times 2n to the 6th power. So the first thing that you would need to do is simplify this with the power, go back, with the power rule, okay? So if we do the power rule on this, this is telling us that we have 6 sets of 2n. So 2n, 2 times n, 2 times n, 2 times n, 2 times n. 1, 2, 3, 4, 5, and 2 times n. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. So we have 64n, 1, 2, 3, 4, 5, 6, to the 6th power. So now we have 2n to the 8th times 64n to the 6th. And now we have to think back to our first rule that you learned, which was the product rule. So we will multiply our coefficients, and then we will add our exponents. So to multiply our coefficients, 2 times 64, that would give us 128, and then we add our exponents. 8 plus 6 is 14. So it would be 128n to the 14th as our answer. All right, I know some of these were tough, especially 9 through 12. They were tough. So it looks like you got, oops, yeah. Oh goodness. Looks like you got 1, 2, 3, 4, 5. Out of 12 correct. So like I said, next week I'd like to give you some more problems to do, to solve, and then we'll work through those together. If you have any questions, send me an email.